BioSphere approach. In the previous lesson, we explored the foundations of emerging sustainable materials, including their classification into the biosphere and textsphere, key sustainability criteria, and the importance of a life cycle perspective. In this lesson, we will focus specifically on the biosphere, examining materials derived from natural, renewable, and biologically grown sources. We will look at bio-based materials, materials from biological waste, and living materials, exploring case studies and real-world applications to understand how these approaches contribute to sustainable and circular design in the textile and clothing sector. These materials are derived from renewable biological sources, such as plants or animals. They are processed into fibres, polymers, or coatings. Examples include cotton, hemp, flax, bamboo, bioplastics, and bio-based leather alternatives. This diagram maps how bio-based resources from plants, algae, animals, and microorganisms are transformed through intermediate compounds like cellulose, lignin, and proteins into a wide range of sustainable materials and applications. Flax is a low-impact, rain-fed crop that naturally stores CO2. It is a natural bio-based material derived from the flax plant, Linum usitatissimum, and used to produce linen, a plant-based fibre with minimal chemical processing, especially when organically cultivated. Thanks to its mechanical strength, flax fibres can also be used to reinforce bio-based composites. Cactus leather is a bio-based material made from organic nopal cactus leaves, Opuntia ficus indica. The leaves are harvested, sun-dried, and processed into a leather alternative. However, it is not a purely natural material. It is a bio-based composite that typically combines cactus biomass with bio-based polymers such as PLA or other plant-based binders to improve durability and flexibility. Both materials belong to the category of bio-based materials, but they differ in their level of processing and structure. Flax is a natural bio-based fibre with minimal processing, while cactus leather is an engineered bio-based composite. These materials are created from organic residues or byproducts of agricultural, food, or industrial processes. They transform waste into valuable new resources. Examples include materials from orange peels, coffee grounds, grape skins, or shellfish. One sample is organoid piva, is a biocomposite made from untreated vegetable fibres and natural binders, keeping the raw materials recognisable while remaining fully biodegradable. This fabric, developed from 100% recycled apple waste, including cores, seeds, and pomace, transforms what would otherwise be agricultural waste into a flexible, durable, and water-resistant material suitable for accessories, fashion, and interiors. Living materials are grown using biological systems such as fungi, bacteria, algae, or mycelium. They represent an intersection between biotechnology, design, and sustainability. Examples include mycelium leather, bacterial cellulose, and algae-based dyes. An example of a living material is mylo, a sustainable, bio-origin material made from the root-like structures of fungi. It's grown quickly, biodegradable, and can be processed to have a leather-like texture, often used in fashion and upholstery as an alternative to animal leather. Faber Futures develops living textile materials by harnessing microbes like Streptomyces collicolor to create natural dyes, demonstrating how bacteria can be used as sustainable partners in material design. Bio-based and living materials contribute to more sustainable textile systems. By reducing dependence on fossil-based resources, they enable renewable and low-impact material flows. In addition, the valorization of biological waste and the development of engineered living systems, such as mycelium-based materials and microbial dyes, demonstrate the potential for functional, biodegradable, and regenerative solutions. Overall, integrating these approaches into design strategies supports the transition towards more circular and sustainable material systems in the textile and clothing industry.